Like a interview type of thing. Okay, okay, I am in the story and I'm asking this question. Okay, okay. Sir,
You're in line.
So,
Questions. Already the questions came, right? You will ask the question and you have to answer.
oh, it is not like online somebody.
They will come, sir. Till now they didn't come.
Okay.
they will type the question.
Yeah, they will type the questions and the question will be appear here. You can say.
You can start it, sir. You can
You can ask.
shall I ask?
Yeah.
So is it a mock or it is final?
It's fine. It is fine.
Final.
So the student had sent that question through Google Forms, so I think.
Sir, what is the difference between PLLA and PDLA? Which one is preferred as biomaterial implant in humans?
Yeah, so PLLA and PDLA, the major difference is that in terms of the molecular weight, and also this among this between the two materials, PLLA is more used, and then I think clinical trials are to be conducted for specific targeted applications. Then one can use them in humans. As you remember that without clinical trials, no material is allowed to be used for human healthcare applications.
Thank you, sir. The next question, which type of biomaterials implants is widely used in human body, polymers, metals or ceramics? With respect to multiple locations in human body, that is for example, hand, arm, femur or skull.
Yeah, so all the three materials, and these polymers, ceramics, and metals, they are used for applications in different anatomical locations in human body. For example, um, for dental applications, dental restorative applications, these materials which are used is glass ceramic materials, ceramic based materials. Nowadays people use all ceramic implants, like even the crown as well as dental implant, all is ceramic based materials. If you go for this femur, or that, for older patients, then when they undergo hip fracture, then what will happen? Total hip joint replacement, whatever materials they use, that is a classic examples where metals, ceramics, and polymers, all three can be used in combination. For example, in the total hip joint replacement, if you have the femur, which is or stem part of the femur, which can be used, which is made up of the titanium based metals or stainless steel based implants. Then it has a femoral head, which is typically made up of the alumina or zirconia for better wear resistance properties. And then this femoral head always in contact with acetabular liner or socket, and this is made up of the ultra high polyethylene, which is a classical example of polymer. So similarly, in the knee replacement, also total knee joint replacement, people use ultra-high polyethylene or cobalt chrome based alloys. So if somebody would ask, I would say that metals are much widely used for applications, for biomedical applications in humans, followed by polymers. And uh, compared to these two metals and polymers, I think ceramics are used much less.
Next question, sir, is there any possibility of questions from assignment for final exam? Where can I find your book for biomaterial science and tissue engineering principles and methods in the PDF format for free?
Yeah, these questions can be, some of the questions can be repeated, but these questions will be, the options will be different, so that the same identical questions may not be repeated. The books are quite cheap because it's a student friendly book, so for the students only we have kept the price as kind of 1,000 rupees or even less than 1,000 rupees, I think, which compared to the kind of didactic value of this book, I think this price is quite competitive.
So what are the broad areas of application of hydroxyapatite?
So hydroxyapatite is widely used for dental applications. Hydroxyapatite is used also as a coatings on the stem part of the total hip joint replacement. So hydroxyapatite is also used as the bone fillers. For example, any orthopedic surgery, if there is certain gap between the implant as well as the host bone, that gap is normally filled by hydroxyapatite because it's a uh, highly biocompatible material, and hydroxyapatite is the inorganic composition of the natural bone, so their biocompatibility is not questioned.
Next question from Kiran. I have fabricated some calcium sulfate based scaffolds using 3D powder bed jet printer. Scaffolds have different pore, strut, and shapes. I have done dimensional and compression strength analysis of scaffolds with different layer thickness and orientation, and also tested with SEM and PXRD. In future, I want to fabricate same scaffolds with tricalcium phosphate at different percentage mixtures. Please suggest me some biological test which can be done in vitro for the fabricated scaffolds.
Yeah, so biological test certainly what you can do is that since it is a tricalcium phosphate, it is a bioresorbable ceramic. So you can first thing you should see that depending on the TCP content, how this how their dissolution in the simulated body fluid takes place, and you can do some kinetic analysis, and you can use this simulated body fluid also. The second question is that the second issue is that in this tricalcium phosphate, just to see that 3D printed structure has similar biocompatibility like a normal conventionally sintered materials. You can do the cell compatibility or cytocompatibility study using fibroblast cells or osteoblast cells. You can grow these cells for different time point in culture at 37 degrees Celsius in cell culture medium at pH 7.4 inside the incubator, and you can quantitatively estimate that what are the number of cells, how the number of cells will adhere, and then they're viable using that MTTS and so on. So these are the two biological tests that you can think of conducting to establish the biomedical potential of these materials. So Ajay, your question is how to improve adhesion property of a coated layer on a substrate using sputtering, for example, metal target or other metal substrate. Adhesion property means, I guess you are adhesion means, I think you are asking about the cell adhesion property, right? So one of the ways that you can use that you can coat the material with fibrinogen as a protein, and this normally and normally once you coat this material with a protein, then what would happen is that that material would adhere would this material. So suppose if you have a coated substrate. Okay, so layer adhesion on the substrate. Okay, so your question is the layer adhesion on the substrate. So essentially, for that, your metal should be, first of all, you have to roughen the substrate. So once you roughen the substrate, you can do roughen the substrate either by sandblasting or by short pinning. So by any of these procedures, if you can roughen the substrate, the adhesion of the coating would be much better. Okay. Any other question? What is your exact question? So if they have a different, this can be. So your question is that whether, so if they are improve, how to improve the adhesion of layer on the substrate if both the coating substrate have high difference in elastic modulus. Um, uh, I think this roughening the substrate will solve the purpose, because I'll tell you the example. For example, stainless steel is often coated with hydroxyapatite for biomedical application. So stainless steel has a elastic modulus of 210 gigapascal, whereas hydroxyapatite has a roughness of, maybe around 1/4, like 50 to 60 gigapascal, or even less than that. So hydroxyapatite coating on stainless steel is not a problem. The same is for titanium. Again, for titanium and hydroxyapatite has large difference in elastic modulus. Item that you write at the rate OJI so that people understand what it is.
Can you explain the compressive behavior?
Yeah, polymers typically they are viscoelastic materials. So this viscoelasticity essentially means they behave like their behavior can be described as a combination of the viscous fluid and elastic solid. So so viscous fluid and elastic solid, and therefore when you uh, compress them, so their macromolecular structure will be deformed, and then it all depends on what kind of polymers you are talking about, because there are thermoplastic polymer, there are thermosetting polymer, and there are elastomers. So depending on the macromolecular structure and the other characteristics, their compressive response also would be different. any stainless steel is coated with magnesium. I am not sure of any literature where I have seen magnesium coating on stainless steel, but typically hydroxyapatite is coated on magnesium. That I remember that people have investigated. They have copied it. इसको पूछो कि इसको क्या रिटर्न आंसर चाहिए नहीं हम लोग जो इधर करते हैं Vijay, that one of the Vinay, one of the important aspect for magnesium is the corrosion resistance. So these particularly magnesium alloys are much lighter, and once their corrosion resistance in the biological environment is well established, they will be they can be used for different biomedical applications. Now to sum up, magnesium alloys as biodegradable implants are certainly compatible for bone tissue engineering applications. Yeah. So, Rakesh, these experiments that you can do for the scaffolds are as follows. The first one is that you can do mechanical testing to see that elastic modulus as well as the strength of the scaffold, particularly the compression tests, because scaffolds are essentially porous materials. The second thing is that you have to do 3D cell culture experiments just to see that how cellular ingrowth uh, takes place in this one, in these scaffolds. The third one, 3D cell culture experiments, the second one. 3D cell culture experiments. Third one, you have to do vascularization and angiogenesis. Uh, um, uh, you have to conduct experiments or assays to investigate the vascularization and angiogenesis of the scaffold. And fourth one, you can do in vitro dissolution to see the biodegradation, if any. In vitro dissolution in simulated body fluid. Just try to work it. You make it. Just check the email. Okay. See this metal MAO process to perform coating on metals, it all depends on what is the substrate composition and what is the coating composition. Without that, it's very difficult to tell any optimized parameters. Uh, these implants, particularly for different age groups, should be different. For example, if they for the pediatric orthopedics, the kids have to run, their daily activities will be uh, more than 75 years old patient. So therefore, the answer is that same material implant cannot be used, but with a variation of the same material implant with better fatigue resistance properties, with better durability, should be used for patients with younger age compared to patients with older age. Different actually, therefore the same implant materials with different variations, with different um, properties, for example better fatigue resistance or better durability properties, should be used for younger patients. Any other question? For degradation solutions, hand solution is better. Yeah, uh, any standard procedures means you can use this Hanks balanced salt solution, and you can do this test for at least 2 to 4 weeks. But in literature, there are various people, various research groups they use for different time period. You can follow that ISO standards. ISO standards.
over, you can stop.
I don't know what is that.
I said, if it is over, you can stop.
I'm asking any other questions.
There is no questions.
Let them ask. What is the slots you have given?
Sir?
What are the slots level 4 to 4:30?
No, sir. It started 4. If you want, if it is over, you can stop. Like that.
No, but they are not given any time that 4 to 4:30 or 4 to 5.
No, sir. Starting time only 4.
But they said 4 to 6 o'clock or something. No.
The maximum time you can start within that time. Still coming. Then you can continue.
So laser is laser modification of the surface can change the stress state or roughness of the roughness, and therefore it can influence cell functionality. Any other questions? Yes, you can, and mark a copy to
6494 Gmail. can stop.
Stop.
Yes.
Then again 5 to 6.
Don't. This much is
No? Asking. Thank you for that answer. This is, I'll stop it here. Video.
I will stop.
चलो जी कॉफी पीना है